Okay, let's go ahead and look at these problems together. Number 1 says Adrian has a savings bond worth $300. It increases in value 3.2% every year. And we want to write a function rule. What do we notice in this problem? What does it tell us that it's doing? It increases by 3.2% each year. What does that increases tell us? It goes up. It's getting bigger. It's growing. That's addition, yeah. Do we know what our formula is for when something is growing? Our exponential growth formula? That's our exponential function. What is our formula when we have exponential growth? That's the one that's A equals P times the value of 1 plus R raised to the T. What's that? P is going to be 300. Yeah, absolutely. So now we've got what function we want to use. We know what variables we're trying to fill. So we can look back at our problem and say $300. That's what it's worth to start. That's our starting amount. So $300 is our principal amount, our P. What else do we know? Yeah, so our rate is 3.2%. But we don't just leave it like that. We divide it by 100. We get 0.032. Then we can put all of that into our problem. Do we have a time yet? Do we have a time yet? It is every year, but we're just going to leave it as T for now. Because when we look at the next problem, what's our time? 10 years, exactly. That's going to be our T. So when we have a T for time, that variable, that's going to tell us every year. And then we want to know what to put in, how many years that is. So that's where it tells us 10 years. But now we know where we put that 10. We bring everything down. And we put our 10 where our T is. Now this is a good stopping point on our paper, and we can put it into our calculator here. What value do we get when we put it in our calculator? You have a value? Yeah, that looks great. $411.07. And we stop at 0.7 because it's money, and it told us to round to the nearest penny. That's 2 decimal spots. The last part of that problem is we have to bubble it in the grid. So I put every number and decimal into their own columns. And I fill in those bubbles. What questions do we have about problem 1? Nothing? We feel good about it? So we looked in the problem, we figured out which function rule to use. Then after we got that, we knew which variables to fill. So we found our 300, and we found our rate. Problem 2 says factor this expression. What's the first thing we have to look for when we're factoring? The GCF. Do we have a GCF? Yeah. What's our GCF?
6.
All right. So if I divide every term by 6, I can rewrite this as 2x squared plus x minus 6. Now what's my next step? The big cross, yeah. Or x. Okay, I just rewrote.
It will be 12 on top and 1 on the bottom.
Okay, so I heard 12 on top and 1 on the bottom. Negative 12. There you go. Good catch. So on the top we did our a times c. That was 2 times negative 6 in our simplified version. On the bottom we have 1. What two numbers, when multiplied together, are negative 12, and when added are 1? Negative 3 and 4. Nice. So we have 4 times negative 3, that checks out. It's negative 12. 4 plus negative 3 is 1. All right, are we done? No, because our a is not 1. So what do we do now? We have our box. What do I put into this top left box?
12x.
12x squared. We could do 12x squared. We could use our simplified version too. So if I use this simplified version, 2x squared plus x minus 6, what goes in my top left box? 2, and I bring everything with it. I have 2x squared. So I bring all of the terms. What about that bottom right? This one right here. 1. So I'm going to look. Yeah, negative 6. So I look back at the whole expression. And then this is where I use what I just found, my 4 and my negative 3. I put those in our other boxes with 4x and negative 3x. What is the greatest common factor of 2x squared and negative 3x? X. Yeah, just x. What about 4x and negative 6? Just 2. Yeah. What about 2x squared and 4x? 2. 2x. And our last one is negative 3x and negative 6. It'd be negative 3. Negative 3. So when we write our factors, we have x plus 2, 2x minus 3, and we bring our GCF down with us. What questions do we have about the Bellwork problems? We feel good about those? Okay.